Hi, my name is Mark Abrams, and I'm with the enterprise Linux company called Suse. You are joining the Cloud Native at the Edge and Other Open Secrets session. And I would like to take this presentation time to talk to you about a major shift that's happening in computing. We'll talk about what is Cloud Native. We'll talk about what's happening with Cloud Native at the Edge today. And we'll even take a look into the possible future of Cloud Native at the Edge. I think everybody has an idea of what Cloud Native is. However, I'd like to sort of level set around Cloud Native so that when we have the discussion about Cloud Native at the Edge, we have a foundation. So first of all, Cloud Native brings some app development consistency. It also is important when it comes to availability of resources, especially it was originally designed for creating general availability to CPU and RAM for those same applications. And then there is also just a general set of common utilities that are available with the Cloud Native process, especially in a single container orchestration system like Kubernetes that allows for app deployment to any infrastructure. And then we get things like reliability and scalability and of course availability that I just mentioned. And finally, Cloud Native has also brought in this process model, something that people call DevOps. DevOps is developer operations, essentially giving more control to the developer to bring an application all the way from the development process to production, so giving developers even control over the operations side, as opposed to having developers just toss a script over the walls for how this is going to run in production. Developers are getting hands-on in the production environments as well. This is a quote from the developer of the Atari 2600 game known as Adventure. This was one of my favorite games growing up. And what I find interesting about this time period is that a single developer did everything. This was a new frontier. It's easy for us to take for granted the advancements that came after this, things like graphics drivers, parallax layers, 16 and 32-bit systems. But, well, how does this relate to DevOps? I think we're back to putting a full solution on the shoulders of a single developer. And I think there's a cycle here. When we see individuals making significant contributions to large ecosystems, we're about to experience a sea change in the environment. So eventually we move from individuals back to process and assembly and manufacturing processes. Here's an example with the bicycle. So back in the 1970s, the bicycle down at the bottom bracket, it had about more than 20 parts to make the pedals go around. And this was called the bottom bracket, and it had ball bearings and these things called cups, a spindle, a lock ring, and a dust cover. Today, this is just two parts. And this modularity has lent itself to going from having a very skilled mechanic be able to update, manage, replace these bottom brackets, to having the ability to, first of all, do it in a much more simple fashion, less skill from a human individual, but also machine automation can insert and install these things in a new bicycle with ease. Cloud Native brings modularity to the software stack just like we had in the bicycle. So I can get things with Cloud Native like scalability, where I increase the number of these triangle microservices. I can also get reliability, which means that if something happens to my application and part of the application fails, it's okay because the system is reliable enough to stand it back up. And what's interesting is that if we orchestrate across multiple hardware devices, we can achieve what is known as high availability. With this, we can even lose a piece of hardware and still have our applications recover, because the underlying system handles availability, scalability, and reliability for us if we build it according to the standards. This is a quote from the Eclipse Foundation EdgeOps white paper. It highlights a few things. First of all, note the term EdgeOps. Yep, that's DevOps for edge deployments. And the quote is also addressing the challenges of heterogeneous hardware at the edge. Differing requirements make it challenging to broadly standardize edge computing hardware. Okay, I think with container orchestration, we've got that covered. The edge is different than the cloud. However, it's not so different. And the similarities really lend themselves to using cloud-native practices at the edge. As I said, cloud-native was designed originally for general access to CPU and RAM resources. And as you know, this is in part achievable because we have, in the cloud, we have homogeneous commodity hardware securely housed in a nicely cooled network data center with plenty of storage to go around. So, yeah, the edge is not that. The edge, of course, is a set of heterogeneous systems in these zero trust environments, often with limited resources, though and not always, right? Often spotty networks, and sometimes it's just whatever memory we might have on board. For sure, the edge is different. No question about that. Under the hood, though, they both have hardware and an operating system or firmware and some way to interface with a human or other systems. The cloud-native approach gives us the ability to abstract the heterogeneity of hardware away from the software that runs on it. Through configuration, device targets can be systematically mapped to specific software using affinity and anti-affinity methods. So if I have a pod which requires FPGA, that's fine. I can target that using container orchestration. If I have a pod that needs I2C, yep, no problem. I can also target that. And if I have a pod, another pod that needs access to the network interface controller, sure, no problem. I can access that too. So, of course, these are all possible because they're simply resources. Originally CPU and RAM, but Kubernetes has the ability to allow your workloads to access all sorts of resources that we see on edge devices. The edge has an unbounded set of resources, but practically speaking, every enterprise has a finite and known set that they need to operate on. In Kubernetes, which is one model for container orchestration, these are simply resources which microservices can get access to. So why do we call it cloud native at the edge? Well, right now, that's really just a name. It's easier to reference cloud native at the edge because people know what that means in general, and we can use metaphors to get us further in the game, right? It's changing. As you saw, we are already hearing terms like EdgeOps. We're also hearing terms like Edge Native pop up. But the thing is, the modularity of cloud native is more capable than just what's happening in the sanitized data center. There's no question that the edge will benefit from process that is more rapid and secure and fungible. Cloud native has already developed a lot of these things for us. We also have some other capabilities at the edge that the data center doesn't have. Any connected device can be a target resource for a containerized software workload, as I just showed. We have more hardware. There's vastly more physical devices at the edge than all of the data centers combined, and if not today, there certainly will be. In addition, the sheer number of devices at the edge begs for systematic development and automation. Cloud native can give us these things as well. The reality is that regardless of where the system resides, they all have common subsystem needs, which is an abstraction that container orchestration handles extremely well. Whether the resources to be accessed are the CPU, the RAM, or things like FPGAs, GPUs, TPUs, NICs, serial buses, radios, the cloud native approach provides a much needed separation of concerns. So we can, separate out things like security, lifecycle management, get application isolation, so multi-tenancy, declarative deployments, packaging for those applications to be deployed, dependency management, resource management, etc. The list goes on. So here I have on the left side, I have a city building, and that represents our cloud. And on the right side, I've got this little home in the country, right? They obviously have different needs, but they both have common modern utilities, right? So they still both need plumbing. They still both need electrical. They still have windows, walls, doors, rooms, spaces, right? General utilities. And this is what Cloud Native brings us at the edge. Cloud Native at the edge is not just a proposal for the future. It's actually happening today. This is a short list of industries where Suse and Rancher Labs are working, and we actually have customers and just users of our projects and our products in these verticals doing Cloud Native at the edge today. And not only are we seeing individual industries or enterprises taking on Cloud Native projects, we're seeing consortiums and cross-collaboration of Cloud Native. So the Sophie project, for example, was recently announced by ARM and is a cross-industry collaboration developing a scalable open architecture for embedded edge. The second one I've listed here, the European Commission, has an open call for proposals for a collaborative effort to build a meta operating system which spans resources, physical resources at the edge. This is listed under their Research and Innovation Action section. There are other groups which we're working with which are still unannounced, and I cannot mention them today. So these are some of the things that are drifting in with the sea change that's happening as Cloud Native makes its way to the edge. We're seeing a separation of the embedded operating system from userland. We're seeing a design from the ground up for Zero Trust. We're seeing the move from GitOps to EdgeOps. I didn't really talk about GitOps, I talked about DevOps. GitOps is a process model for moving code into production through the commit lifecycle process. We're also seeing a general separation of concerns, building blocks, so to speak. So building the base blocks that are needed to bring Cloud Native to the edge. This is kind of cool to me because I love Legos, and could it get any better than this? Building these small components of physical hardware and the piece parts that make up the software, and making them really just componentized and being able to stack them on top of each other and make new things. It's a new stack. Security, local storage, new communications channels. So where we might have used the system bus before, maybe we're going to use TCP/IP to communicate, or maybe we use both. I mean, the options are open. We're not locking ourselves out of the existing solutions. In addition, we're getting consistent APIs. I thought it would be interesting to summarize with some of the headlines that we're seeing if you search for Cloud Native at the edge. At least this is what I got from Fastly: becoming edge native in your application design. From Tech Radar: edge computing today, tomorrow, and into the future. From Tom's Hardware, of course, you may have already heard ARM's position on this, but ARM says performance per watt is the new Moore's Law. And finally, from the Container Journal: Google and Ubisoft push Kubernetes for video game industry. This is really interesting to me, to use container orchestration for video games. It's already happening, but it's an interesting prospect that we might see gaming in distributed systems using container orchestration. So that was a brief summary of Cloud Native at the Edge and where it is today. I'm going to take you now into my opinionated perspective based on my worldview of working in container orchestration for the last 6 years and having a focus on container orchestration at the edge for the last 3 years. These are both so container orchestration is obviously fairly new technology, and container orchestration at the edge, of course, is very new as well. Please, these are my opinionated perspectives. Please reach out to me on social media. If we see each other in person, I recognize that these are opinions, and I value a true discussion. I'd love to get your feedback and hear what you're doing or why you think things might be different. I think we're going to see consumer-grade distributed systems. In the center picture, this is something I built. I call it my Edge Cyber Deck, and I use it for demos and development. And in that middle picture, the board on the left, the larger board, is called a Turing Pi. Now that's version 1 of the Turing Pi, and that you're seeing in the picture, and it has 7 Raspberry Pi Compute Module 3+ slots, and they're all loaded up. And they just announced version 2 of the board. Version 2 is going to allow for 4 Raspberry Pi Compute Module 4s. And while I was a little disappointed with the reduction in the number of compute modules, of course, they're more powerful. And each of the slots allowing for the compute module will also allow me to put in an NVIDIA Jetson module. Now you can see that I've already added a Jetson module. In the lower right-hand side of this picture is my Jetson, but it means that I can drop in this replacement board. It will have a small cluster and potentially the capability to have GPU and machine learning inference built right into that single board. I may redesign this whole thing despite the fact that it's drop-in, but I think we're going to see overall, distributed systems at the consumer level. Who would benefit from this, right? So, of course, cloud developers would benefit. Data scientists would benefit from this. Edge developers would benefit. And I actually think it's not that far a stretch to say that the general public would benefit. They may not care initially. They may not care at all that there's a distributed system under the hood. But if you tell them that they could have features not present in their machines today, like redundant storage, that could be a very nice selling point. It won't be long before we see aggregated consumable edge resources. The edge will provide resources unavailable in the data center or cloud, and resources which we can get only from edge deployments. For example, where the data is being produced. That is one definition of the edge, right? And prior to the hyperscalers, leasing someone else's compute power using APIs to simply drop applications in place, that didn't exist. And today, an edge cloud does not exist. I believe it will. Already, the hyperscalers and the telcos are trying to create their own edge clouds. Who's going to succeed in creating the next edge cloud or the first edge cloud? Will it be an incumbent or will it be a disruptive innovator? Your guess is as good as mine. I believe that reduced footprint container orchestration is going to become something of a necessity. Currently, cloud native has a cliff when it comes to small, tiny devices, resource-constrained devices, because cloud native requires a certain minimum CPU and RAM that's not available on those devices. So what can we do about that? I think we'll do what we've always done. We might build smaller devices with more power, like this Raspberry Pi change. We might build hardware components that handle scheduling of containers. So if we had a SOM that actually implemented the kubelet, which is the agent side of the scheduling, then we could put that on any device, really. We also might just build smaller footprint software, basically building container orchestration that has a reduced footprint that can go on smaller devices. So I think as innovators, we'll find a way. We always do. This type of problem hasn't really stopped us in the past, and I don't expect it will now. So this might be a stretch for some, but I think we're going to see some blockchain implementations. I think smart contracts for things like secure device onboarding or device intra-networking will be really valuable. Social networks are an emergent property of human interaction. Digital social networks became essentially a new pathway for our communication. And in just a few short years, we already take the tool sets for granted and expect our digital communications to always be robust and dynamic. But social has not been closely tied to a classical technology. In fact, we stereotype our technical people as antisocial. And my guess is that with this audience, that most of you know that this is just not true. It's incorrect, right? Engineers are quite social in context to what they know. So what better way for our systems to be social than smart contracts? To me, this looks like the machinery and glue that will aggregate our systems in ways previously unimagined. With the advancement of having edge clouds and some high-level operating system to access those resources, which may reside in someone else's physical location, right? We're going to see the need for and the development of smart contracts for all sorts of things around edge computing. This adds a layer of security, it adds a layer of communication, it can help us onboard, lots of things. These contracts will enable us to make agreements on who can do what, when, and where. And of course, the who might be devices themselves, not just people. Let's talk more about the sea change. If you look at this retrospective of distributed systems for the last 60 years, you can see that we've had mostly centralized systems up until the early 2000s. At that point, we start to see an uptick in decentralization. In 2006, EC2 was introduced, that's Elastic Cloud from AWS. And in 2007, consumers get the power of computing in their hand by way of the iPhone. So looking back and basically looking at where we've been, cloud native as a model looks like a very natural extension of computing in the past. And this is good. We don't want a revolution in computing. Revolution has a way with uncertain endings. What we want to see is evolution. Evolution is it's an expression of natural progress, right? It's manageable. Things become sort of ordinary through evolution. Container orchestration, the software at the heart of what is now cloud native computing, was popularized by an open source project called Kubernetes. If you don't know the history of Kubernetes, it's an offshoot from Google's internal cloud compute, which was termed the Borg, named, of course, for the robotic alien race in the popular TV series Star Trek. We can already see there is not going to be a single collective like there was in the TV series. There will be many. Even in a single enterprise, we will see many distributed systems. This presentation, the facts and my opinions, are based on interactions with prospects and clients that I've worked with over the years and who are or have now moved their operations to cloud native. I hope you find value in it. I hope to hear from you on social media and in the forums, and even perhaps in person one day soon. Thank you for listening to my presentation. My name is Mark Abrams. I'm a field engineer and edge specialist with Suse and Rancher Labs. I contribute to open source, and you can too.